Well, this is video 11. We are human beings, and this means very often that when we try to fix a situation, we cause a different problem, no? We fix the situation and then a new problem appears. You remember the bottleneck? When we elevate the bottleneck, another bottleneck appears. This happens all the time in many things that we do. In this case, we hired a new worker, so now things go faster. We don't have a perpetual queue. We have a queue that is not very long. You have chances of not queuing if you go there. So now people is happy. People hear about it. I say, okay, I will come back to this business. I quit this business some time ago because I didn't like to queue for so long. So I will give them another opportunity. No? And now what happens is that people is so happy that people come more often to the warehouse. More people come to the warehouse every day. So now we have one client every 16 minutes. So we have clients more often, right? One client every 16 minutes. It means that we have 3.75 clients per hour before we have 3 clients per hour. Well, the good thing about it is that we hired a new worker. This means a new cost, but we will have some more clients. We will stop losing clients probably, and it seems that the result is that we have some more clients, so we will increase the revenue. All right, let's see if this is a good business, because we should increase the revenue more than we increase the costs. Well, let's see if this has been a good solution, because, well, things changed now. Huh? So now we have this arrival rate of 375 clients per hour. The service rate is the same that it was before. We still have these 2 workers. This is still model 3. This doesn't change. Let's work out the ratio, 375 divided by 2.5, this is 1.5. This is more than it was before. It was 1.2, now it's 1.5. There is a risk that there is a perpetual queue, maybe. Well, if we look at the LQ table, we'll see, because this is model 1, we'll see if there is a perpetual queue or not. This. We must go to the second column, as we did before, and we must look for 1.5. 1.5 is here. Second column, we see that there is not a perpetual queue. We see that LQ is 1.9286. 1.9286, so I put it here. 1.9286, and this is the number of customers queuing. As you can see, this is bigger than the one that we got before. So you will arrive there as a customer. It's been a long time, and now I see that there's some people queuing. I don't like this. Let's try and see what happens, right? So at least it's not a perpetual queue. This is good. So 2 people queuing, almost 2. This is an average. So almost 2 people queuing. How long are they queuing? 19286 divided by lambda. That now is different from before. 375, and you will get that this is 2,926. This is 0.514293 hours. This doesn't say so much, so we transform this into minutes and seconds. This is 30.8576 minutes, and this is, we subtract 30 and we multiply by 60, and this is, oh, you don't do that. So this is almost 26 seconds. It's a little bit less, it's 25.728, but let's say that this is 26 seconds. Okay? So this will be 30 minutes and 26 seconds, almost 30 minutes and a half. I'm not so happy as a client, okay? They told me that we don't have these long queues now. I go there, I see 2 people queuing, and if I have to queue, I will queue for a little bit more than half an hour. I don't like this so much. It's not a perpetual queue, but it's longer than before. Before it was 13 minutes and some, no? Let's see about how many people in the system. 19286 plus 1.5. That's now the ratio. 1.5. And this is Remember when I always tell you, don't never use a smartphone as a calculator. I'm doing it because my calculator is at home. She's sleeping. It is Saturday. 5, 3, 4, 2, 6 clients. Okay, so in average we will have 3.42 clients in the system. So between 3 and 4 clients in the system as an average. So you go there, you will see 3, 4 clients, sometimes 5, sometimes 2, but most of the time between 3 and 4. How long are these clients in the system? 3.4286 divided by 375, that is lambda. 375. This is 0.914293 hours. We multiply this by 60, and this is 54.8576 minutes. So 54 minutes is the same thing that we had in here, yes? 26 seconds, a little bit less than 26 seconds. And now is when we can do this checking operation. Is the difference between the total time in the system and the queuing time the service time? 54 minus 30, 24. Okay? 54, 26 minus 30, 26 is 24. Is this the service time? Yeah, this is the service time. So probably we are right. What is the probability of waiting now? That we should say queuing. Which is the probability of waiting or queuing? Okay. Well, LQ is 19286. S is still 2. Mu is still 2.5. Now what is different is lambda. Now is 375. This is different compared to the previous situation. I go into past. Minus 1. Okay? Now, my little smartphone will say if you have to queue, if you don't have to queue, I told you I never use the smartphone as a calculator. Zero 6428. So 64, 28% that you have to queue. All right. So we find a solution that it seems that, well, at least we don't have this perpetual queue. We attract more customers. We are recovering some customers that we had lost, but it seems that we have a long queue here. The chances that you have to queue are higher than before, not much higher, but higher, right? Chances that you don't have to queue will be 35%, 35.some%. What could we do? It seems that when we do something, we have more clients, no? So we could make another decision, like hiring a third worker. That's right. We'll see on the next video.